Okay, so I'm going to try to walk you through a few of these problems that you can see on the screen here from chapter 5, question 41. But real quickly, I want to talk about the difference between present value and future value. Future value is the idea that the money you have today is worth more today than that same amount in the future due to inflation and the loss of value on the dollar over time. So $1,000 that I have today is actually worth more than what I could buy with $1,000 in the future. That's the idea of how we look at present value. Also, sometimes we'll look at it in terms of if I have this much, what is my present value if I want to turn it into another certain future value. The future value is what it could be worth in the future. So what it will be worth according to some set rate and period of time. So in Excel, the first one says assume your rate is 10% each year, and you are investing $1,000, or you want to find the future value of your $1,000. So what the $1,000 would be worth. So really, you're taking the $1,000 and you're multiplying it by that 10% rate. You're earning $100 in the first year. You would add that to your investment, and you would multiply this investment by 10%, which gives me that second line that I calculated to know my second year's interest. Then I would add that to my investment. So I have 1,000 invested. I earned 100 the first year. I earned 110 the second year. I would multiply that on the third year by 10% and so forth, you can see, until the total value becomes $1,610.51. But the formula, instead of doing all of that math, I did both parts. This is manually working it out for you. In Excel, you can go to the future value formula and just input the data that you see up in this bar here. So if I were doing it, I would put insert function, and then we're looking for the future value function. We're going to click that. I've used it before, so it comes up at the top real easily. But you can also type it in the search bar that you want future value. And if it doesn't come up, it's because it references it as FV. And then we're going to input what it tells us in the problem is a 10% rate. Now, I did have to put the percent sign in. The annual, the number of periods this time is 5. We have 5 years. And we're putting it in that we are presently investing $1,000. It's going in as a negative because I am investing that much. And then the last part here, it typically will default that you will earn your interest at the end of the period unless it states otherwise. I know one of the other homework problems does change that the investment begins at the beginning of the period, but if you can leave that type blank, then it's fine. And you also want to leave your payment blank because we're not making annual payments. We're just doing one lump sum investment of $1,000. And then it calculated that exact same answer that I already had done manually. The formula just calculated it for me. So that was my future value formula. Now, if it asked me for, in question part B, it says, calculate all of these totals with different interest rates. Well, the first one is a 0 interest rate, so I'm going to end up only having my $1,000 from year 1 to year 5. Now, the second one says, what if you actually had a 5% interest rate? And I would end up with $1,276.28. And here's the full chart for, this is one answer right here, these highlighted together. Put them in a different color so you can kind of see that they're a different answer. But that is the year when the total investment value after 5 years at 5%, because again, manually what's happening is I'm taking my $1,000, I'm earning 5% on the first year, which is $50, adding it to my investment. And then on that total investment with the interest, I'm multiplying by 5%. And next year I'm earning $52.50. And then I add that to my investment. Then I multiply my 5% by that prior year's amount. But you could have gotten this total without the detail by, again, using that future value formula in Excel. Now this one over here says, what if you didn't have a 5% interest rate? I believe it's a 20% interest rate. This is a separate answer, so there are 3 different answers. First answer really was that you would just have $1,000 after 5 years with 0% rate. And then this one says you'll have 1,276. If you had a 20% rate, you would actually end up earning and turning your $1,000 investment into $2,488.32. Part C transitions from talking about future value to present value. Present value really says how much money do you need now to turn it into a larger sum, or in a sense, what is the amount worth now but could be worth more in the future. So we talk about discounting it back. If we already know what the total that we want it to be is $1,000, what money do we need to start with? What would our initial investment have to be? And so this was the final answer here, but I did use the present value formula in order to come up with that. I'll walk you through it again. If you go up to inserting the function, and this time we want to use the PV, the present value, this amount should be smaller than 1,000. I believe the problem says it is a 10% rate, and it is 5 years, so 5 periods, and our future value is 1,000. But we want to know what that would presently look like, and the answer is $620.92, also something I had done here with the formula. So manually what it says is I tried to work it out for you, that I want my total answer to be 1,000 down here, but I didn't know what this top $620.92 should be. But I did know that when I took my year 4 total and I multiplied it by the interest rate of 10%, and then I added it with whatever I had that had to equal 1,000. So what I'm saying is this $1,000 actually represents 110% of some value that I don't know what it is. And so that's how I manually figured out these numbers, is I took 1,000 and I divided it by 110%, which is 1.1, and I got $909.09. If I multiply that by the interest rate, it double checked my figure. So I just had to keep going up this list to come up with the 826. I divided it by I took that number that was here, and I divided it by 110%. That's how I got this year before investment amount. Again, it really says I had to figure out the 620 manually, because what I knew is I wanted my total investment to equal $1,000, and I knew it was a 10% rate. I knew I was earning 10%. So whenever I took 1,000 and I divided it by 110%, which is also known as 1.1, it gave me this answer that year 4 investment had to be $909.09. And I just kept working my way up the chart, and these were the total interest I'd earned every year, and it double checked my chart. But Excel just does that work for you, and that's the point of using those formulas. Is all I had to plug in were those 3 known data points. When I showed it to you here on the formula sheet, really, I had to plug in the rate, the period, and then the future value. I knew I wanted to turn it into $1,000, but I didn't know how much money I needed to start with, and so Excel solved that for me. I needed to start with $620.92. Now on part D, the manual chart here is really difficult. You have to kind of trial and error it to get to this right answer. So it's way easier to use the Excel formula. But basically what it says is you want to take $1,000 and turn it into $2,000. But we don't know what kind of interest rate we would need to earn on that. We do know that they want to invest for 5 years. So we go to the formula thing again, and we use the rate formula, and we put in our 5-year period in NPR as your periods. You know you presently have $1,000 that you're paying in towards this. You want to turn it into $2,000. There's nothing in the payment MPT box because we're not making annual or monthly payments. We're just having a lump sum here. And then I always defaulted to 0, that the interest would be earned and accrued at the end of the period, unless it says otherwise. And it calculated that rate for me. Now my chart double checks that, because it says, hey, if you start with $1,000 and you multiply it by 14.87%, you get $148.70. You add that to your investment, and then you keep multiplying the interest rate by what your current investment is, and it will come up to $2,000. Then this formula says we're going to take our, it's part E, how long would it take us to turn 36.5 million people, or it talks about a population, into double that, or 73 million. So with a 2% growth rate, you're going to use the NPER formula. And really, as for my rate, I put it in with the percent sign. I know that I presently have 36.5 million, and I want to turn it into double that, is 73 million. And it gives me the time. It gave me 35 years as the answer. Then part F, it says if you have an annuity, which means basically now you are making monthly payments, it's not a lump sum, what would the present value of your $1,000 be if you had to enter in $1,000 each year for this investment? So we use the present value. They're really saying, what does that look like, that value today? It would look like $3,352.16. In theory, that's equal to the same thing as having $1,000 and investing it each year for 5 years at 15%. And the way we came up with that number was to use the present value formula on Excel. Again, I just type in my rate with the percent key. I know the problem says it's a 5-year. This time I am putting it in the PMT box, because the annuity, I'm investing $1,000 every year. And I'm putting that in as a negative because that's what I am investing. And then it told me what that had to presently be worth. Now, what will that $1,000 invested each year for 5 years at 15% actually total to, or what was the estimated future value? That again is the Excel formula, but this time we're using the FV, which I put in the rate, 15%, 5 years, is again a negative 1,000, but this time I'm not calculating the present value, I'm calculating the future value. You can see that up in the top left corner. It says that actually turns into $6,742.38. Then part G talks about if you had this annuity and you were actually earning the interest at the beginning of the period, it changes it slightly. So really all I did when I plugged in the formula is I put in all our same values, 15%, 5, but I put this to a 1 at the bottom, and that would really say that you're earning your interest at the beginning, and you're investing initially your 1,000 at the beginning of the period. Another way the book explains it is if you put your money in at the beginning of the period, you're actually adding one more period to it. Now it talks about it discounting it back one less period when we talk about present value, saying you would have to invest more as the present value becomes larger, but not by as much as you think, because you actually gaining some interest at the beginning of each year. Same thing down here. I just plugged it into the formula and I changed the last box to a 1 to say that I'm actually earning this money and investing at the beginning of the period, not at the end of the period. And then part H. This is getting to be a long video, so I will try to explain maybe the rest of the homework, see how this video goes for you on a different video if we need to. But part 8 really just uses that same formula that we've been talking about with the future value is what it asked me for on part H. It's though saying that it's compounding semi-annually. So every 6 months, I am actually earning interest. And they're adding it to my investment. So really what's happening there, it's still a 10% rate for the whole year, but they're not going to give me 10% every 6 months on this problem. That's kind of confusing. So we have to change it to a 5% rate in there, and it's actually not 5 years, and I mean 5 periods, it's actually 10 periods because it's 5 years, but each year holds 2 periods, 6 months semi-annually. So 6 months from January to June, let's say if you started in January, and then July to December, that would be 2 periods in 1 year, but we're investing for 5 years, so we have a 10 period investment. And then the present value is still talking about investing $1,000. So what would that actually look like in the future? It says your answer is you would turn that into $1,628.89, which is comparable to the first answer, if you remember right, $1,610 at the very, very top. Only thing that we did was changed it to a semi-annual rate, so they're actually accruing interest faster every 6 months, and that's why this number in the future is larger. Now, the present value of that investment, what would we have to invest now? Up here it said we would have to invest $620 on Part C and 92 cents. But if they actually give us interest every 6 months, we don't have to invest as much to start with. Or what does that look like at the beginning? And its equivalency to, it would be $613.91. So that is also the formula. But again, how I changed it here is that it says it's not a 10%, it's a 5% this time because I'm getting 10% for the total, but each period I'm really only getting 5%. So H is a little funky, but really it's more or less, I may try to send you a document and ask you to do these things, plugging in, watching my video, plugging in the formula, but plugging in the right values to the formula. Really, on this assignment, we've just used the PV, the FV, we used the NPER and the rate one, but understanding how those work. So I will shoot you an email and see if this video helped or not.